Good evening. I'd like to welcome you to this fourth in a series of lectures on science, technology, and the future. These lectures have been co-sponsored by the Department of Philosophy, the Program in Molecular, Cellular, and Developmental Biology, the Departments of Psychology, Computer Science, and Political Science, the Program on Technology and Social Change, the College of Science and Humanities, the Graduate College, the Franklin J. Machette Foundation, and the ISU Committee on Lectures. Previous lectures in this series dealt with the topics of value judgments in science, models of decision-making in science, and technology and democracy. This evening's lecture deals with some of the issues raised by recent developments in genetic engineering. In a sense, all the previous topics in this series are brought into play when one begins to consider the relationships between genetic engineering, technology, and the role of science in our society. So this evening's topic seems a fitting culmination of the lecture series that began last fall. Our lecturer this evening is in many ways particularly well suited to the topic at hand. Professor June Goodfield, who is currently an adjunct professor at Rockefeller University and an associate scientist at the Sloan Kettering Institute for Cancer Research in New York City, combines the talents of the historian of science with that of the researcher and reporter of developments in research science and medical ethics. She is the author of a work on the growth of scientific physiology, which deals with the mechanism-vitalism controversy in 19th century biology, and the co-author of three significant works in the history of science: The Fabric of the Heavens, The Discovery of Time, and The Architecture of Matter. She has also made other noteworthy contributions to the history and philosophy of biology. In addition, she is the author of The Siege of Cancer and more recently of Playing God, Genetic Engineering and the Manipulation of Life. She has written on topics in medical ethics, and she has also produced a number of science films, including one which won a bronze medal at Venice in 1964. She has also written a novel called Courier to Peking. Professor Goodfield has also been in close contact with researchers in areas such as immunology and has works forthcoming on the history of the recombinant DNA debate, on the two-culture syndrome, and on her experiences with research scientists, which is called A Walk into Science, 3 Years with a Scientist. In her curriculum vitae, Professor Goodfield says that one of her main professional goals has been the interpretation of science to a wider public. There are few, if any, issues which deserve more public attention than those posed by recent developments in genetics. And there are few, if any, individuals who are better suited to articulate and analyze such issues. It is my pleasure to introduce you to Professor Goodfield and hope you will join us for a reception in her honor in the Regency Room immediately after this evening's lecture. Please join me in welcoming Professor June Goodfield.
Bob, do I have to, I'm not very big, do I have to, if I don't pay any attention to those, can you hear me at the back of the room? Yes? Because yes? Because if the recorder doesn't mind, I'd really much prefer to pay no attention to those at all. Point it to me, but I can't see over the top. Bob didn't say, but I would be very happy to deal with any questions after this lecture, but let me forestall one of them immediately by telling you an anecdote. A drunk fell over in New York City and fractured his right hand. He sued the city for failure to maintain the sidewalk. This is a true story, by the way. He sued the city, so my attorney tells me, for failure to maintain the sidewalk. Whereupon the first court, on hearing that he was drunk, drew their own conclusions, which came to the conclusion that the city was in no way to blame for the fracture of his right hand. Whereupon, being a man of some tenacity, he decided to take the case to a higher court, which he did, and which he won. And the judgment was that a drunken man or drunken person, I have to say I was not drunk, a drunken man or drunken person has every right to enjoy a carefully maintained sidewalk and twice as much need as the rest of us. So I think we've dealt with that question. I'm sorry I couldn't come here in the fall. part of the trouble about not coming here in the fall was that it placed a great deal of distance between me and the title that I somehow managed to agree with Robert Hollinger was going to be the title of my lecture. There is this ghastly period of time between when you're buttonholed in England with a very flattering telegram and asked if you will do it, and your resistance is very low because you're on vacation, and you say you will, and then the title comes, and then 6 months when the moment of truth comes, you wonder how on earth you came to agree to this title, or perhaps even what indeed does this title mean. And I think probably that in the last 5 minutes of the lecture I'll get round to the formal construction of this title. But at the moment what I want to talk to you a little bit about is to raise some questions about the issues that have arisen, the kinds of new ethical problems which seem to have arisen or to be arising within science at this time. As Bob said, I did write a book, and it was called Playing God, and I think what I perhaps should explain, because it's as good a little text to my forthcoming sermon as anything will do, I perhaps should explain how I came to be given this title in the first place. It's provocative, and it arouses a great deal of indeed aggressive antagonism in a number of scientists, and I'm so pleased to say that it wasn't my idea. Because when the Asilomar Conference took place, a European microbiologist in the middle of all the angst was heard to turn to one of the reporters and say, nature does not require to be legislated, but playing God does. So the scientists actually, in a kind of way, coined the title themselves. Now, of course, there's an irony here. There's a great irony if we reflect on the time and circumstance in 1972, 3, whatever it was, or 79 or 78, which allows that to be said about science. Because if we think back for the moment to the origins of modern science with the pre-Socratic philosophers in 400 BC, when in Ionia those people set into circulation for the first time the general form of the questions which was going to preoccupy science, and still indeed does preoccupy science, for as its bread and butter fundamental questions. It's ironic that over 2,500 years have passed, and we can now talk about playing God, whereas Epictetus, reflecting on this fantastic realization, which is a fantastic realization, that man's mind, that man had the capacity to reach out and grasp, gain an intellectual grasp of the world in which he lived. And speaking of this, saying of the students that they were cultivating, why then should we be afraid, sorry, I'm quoting, why then should we be afraid to send a young man out into the world? Knows he not the God within? And when Epictetus and the Greek philosophers spoke of the God within man, they realized that there was this fantastic power, which, as I said, had this capacity to reach out. And for them, it was, I'm choosing my words very carefully here, for them it was more than, I mean, it wasn't that you were playing God, it just that the capacity to do this, the capacity and the command, the understanding, the comprehensiveness that rational thought gave you placed man at a position a little lower than God's. It was a godlike characteristic, and it was certainly something not to be feared, and it was certainly something not to be legislated against. It was something to be damn well proud of. It was an absolutely magnificent human attribute of the human mind, and therefore I say that 2,500 years later we've swung a whole great course of science, and the very same capacity could be described by one of its own members as playing God, and something that perhaps had to be legislated against. And so there is the irony. I may say it's not this wasn't suddenly precipitated into history. And it's interesting to think that what might have been going to happen, and ignore my syntax and pay attention to what the thought, please. What might have been going to happen was already anticipated in the 19th century. If you read the De Concord journals, the journals of Jules de Concours and his brothers, who wrote with a kind of sort of French, a dual kind of French Samuel Pepys in the middle of the 19th century within French society. And they went everywhere, and they were entertained, dinner everywhere, and they saw everybody, and they knew everybody, and they wrote it all down. And it's totally delectable to read, because you go out to dinner with them, and you see Madame de this and Monsieur de that, and you see the great French chemist Berthollet, and you meet the great French physiologist Claude Bernard, and you are present at the dinner table conversations. And one day, Jules de Concours comes back and writes in his diary, and I went out to have dinner tonight with Madame de somebody, and I've forgotten her name, and she isn't important. And Berthollet, the chemist, was there, and Claude Bernard was there. And during the course of dinner, the conversation turned to what would science be doing in the next 100 years. And Berthollet said that he prophesied, that what physical science would be doing in the next 100 years would be that men would have such a command of the knowledge of physical chemical processes that they could turn the sun on and off at will. And Claude Bernard said, well, so far as he was concerned, he believed that within 100 years, men would have such a command of the processes of life that they would be able to recreate them in a test tube as they chose. And de Concours puts this note in this journal and says, and I said in the conversation at that point, and believe me, the moment that happens, God will come down from on high and say, as the saloon keeper says at the end of the evening, time, gentlemen, please. And it's incredible that people, even as early back as the 19th century, were able to anticipate the kind of problems and paradoxes that might arise if your intellectual grasp and your intellectual understanding went one step on to manipulation of things that perhaps we shouldn't do, but perhaps we couldn't conceive how we could handle them if we did them. So, of course, this brings me straight into the technique of recombinant DNA, into the period of the advent of that new technique, wildly exciting for scientists, a great technical bonanza, which enables them to do things they didn't think they were going to be able to do, and for many of us, many people, perplexing, for some people, indeed, fearsome. And I have really no idea, Bob, you should have given me a profile of the audience. I have no idea of my audience, really. So let me quickly run quite through the technique of recombinant DNA quickly for those of you who might not know what it is. It really is simply the new device, the new technology, which enables scientists to splice the genetic material from one organism with that of another. Nature is recombining genetic material all the time. Sexual intercourse and the egg that follows is one great recombination act. And it did look at a delectable moment at the Asilomar conference that the NIH were going to bar that under the guidelines. They got round that one all right. But if you consider that the genetic material of any organism literally specifies the instructions, blue hair is coded on this bit of tape, I mean, it just really is like having a cassette of tape in every cell of the body where the nuclei is still there, which is arranged not like a little cassette of material with words, but in fact is arranged in a very complicated spiral staircase, and with the coded instructions for the proteins that that cell is going to make can be read off by a sequence of building blocks along that material. Now, suppose in the middle of this, I know somebody's recording me, and if you want to understand recombinant DNA, all you have to understand is the principle of doctoring tapes. And who in these post-Watergate days does not understand the principle of doctoring tapes? It is all very, very easy. Suppose at this moment in this recording, in this tape recording, I say this is the lousy university, I say this is the finest university I've ever been in. Then that nice gentleman in the yellow wine shirt over there, after the lecture, will scan along the tape. He will then take a pair of scissors, he will cut out the word lousiest, he will go until he finds the word best, he will splice the one into the other, and there we have a perfect a nice recording of all the nice things I'm supposed to be saying now. The principle of recombinant DNA is exactly the same. Scientists can spread out by various beautiful, delectable alchemical means, can spread out the tape from a cell. They can scan along, I'm simplifying it a little bit, they can scan along until they find the particular gene in which they're interested in, for instance, the gene make human insulin. They have discovered the existence of things called restriction enzymes, which are exactly like biological scissors. They cut. And the glorious thing about the restriction enzymes is the uncovenanted bonus for the scientists was this, that one pair of restriction enzymes cutting one piece of DNA will make DNA which will stick to another piece of DNA provided it's been cut by the same restriction enzyme. So, if you have a piece of human genetic engineering, and somewhere deep in the heart of that is the gene for insulin, you straighten the thing out, you scan along until you find the gene for insulin, and you cut there and there, and you cut out the gene for insulin. Meantime, back here, you've got a very simple organism indeed, a plasmid, which is a kind of little virus that infects bacteria. And its DNA is not complicated at all, it's just like a little circle. So you cut it with the same restriction enzyme, and you make a hole in it. And because you cut these two bits with the same restriction enzyme, the two ends are going to stick together, and then you start doctoring the tapes. And you lift out the gene for human insulin, and you splice it very neatly into here, and that is the recombinant bit of the whole story. You have recombined the genetic human gene for insulin into the DNA of a virus. And then you send that to, I don't know, I can't remember what bacteria look like. And you send that, you get that to infect a bacterium. And the idea is that every time the bacterium divides, it will now, so too this will divide. And every time the plasmid will divide, so too will the gene for human insulin. And you all know, I'm sure, how often bacteria divide, millions of them within 24 hours. And the hope is that by doing this, we will make the bacterium be a factory for us, churning out as much human insulin as we want, provided the bacterium obey the instructions. And obeying instructions is a little technical wrinkle that scientists will get around somehow. Now that is basically the technique of recombinant DNA. You have made a molecule, you've done a recombination, and you've produced a living molecule which honestly, to the best of my knowledge, and I think to the best of a lot of scientists' knowledge, have not been made before. It has a lot of great advantages, because what scientists can now do, if this is the whole of the DNA, I mean, and before all this, what they were having to do was to try to study this gene, and they couldn't get it out cleanly, and they had to make volumes and volumes of DNA in order to extract this thing by biochemical means, and it was never, I mean, it was just horrendously difficult. Now, it's as if they can say, it's as if somebody said to me, go to Times Square and find a man with a plaid jacket and spectacles and dark hat and a moustache, go out and fetch it. And you go out very precisely, and they can take out that gene very neatly, and they can study that gene and that effects alone. And so they do see that not only will this be technologically helpful, because it can make the bacteria make things for us that we didn't have before, but also it is a technique that enables us to isolate a gene so precisely and so cleanly that we can study it and it alone very nicely, and that, from the intellectual point of view, is what they want. So is precisely what they would like to do. And clearly, you know, there's nothing wrong about that. There's a great deal of justification for wanting to use this technology, and this is basically what it is. It's a technology, first and foremost, to use this technology so that you can isolate the genes that you're interested in and study them, and so that you can pick them up and eventually, perhaps, make them make things for us. So you have a whole range of advantages to recombinant DNA, which go from the possibility of increasing our fundamental knowledge about the way genes work, the way cells develop, the way cancer genes work, if we can isolate those, to such things as can be such technical payoff as can be, and in fact was predicted by the Nobel laureate David Baltimore talking 2 years ago to a forum on this. Because in Washington at the National Academy. Because he predicted that possibly within 5 years, and probably not later than 10, it would be possible to take a child that had haemophilia, that is, a child that has a defective gene so that the blood clotting factor is missing. And when that child is identified as a very, very small baby as having haemophilia, potential for haemophilia, of taking out the bone marrow, getting the correct gene, splicing it in by this virus technique into a virus, which would then go in and infect the bone marrow cells of that child, thus restoring the normal genetic property, putting the bone marrows, transplanting the bone marrow cells back into the child, and because it's his own bone marrow, there's no problem about immunological rejection, and then for the life of the child, not for his children, but for the life of the child, he has repaired a genetic defect by recombinant DNA. And in that kind of way, you could engineer life forms. Now, I don't think I want to go through, I mean, you can come at me later if you want me to, but I don't think I need to go through. That was the good side of the story, and now for the bad news. And the bad news ran from all the problems about would there, by the use of the bacterium that infects the human gut, by doing these recombinant molecules and giving them, endowing new properties, could you not verdantly or inadvertently set off new series of epidemics through the population, which is the thing that really put the wind up Mayor Vellucci of Boston, and whether in fact you could be giving cancer-forming properties to molecules and to viruses and therefore to bacteria that you didn't have them before, I mean, you can go and soak yourself in these dangers, and some of them indeed are real enough, but I don't want at this point to go through them. But what I really want to do is to raise the questions of what was basically, why was there basically all the fuss? Why the label of playing God? Why did this come to apply in a situation where, on the face of it, all that scientists wanted to do was to extend their understanding and perhaps produce a few nice substances for us on the same way, at the same time. And I want to take this question of why was there all the fuss at two stages and also at two kinds of levels. One is a technical one, and the other is a humanistic one, and this is going to bring in questions of values, and perhaps I think I might manage to demonstrate how, in fact, these two are interrelated. Because, of course, what this is doing is raising and enhancing our capacity to influence events and manipulate the world around us. Owen Chargav's latest book, Heraclitean Fire, which is his own autobiography, said, when I was a scientist, we were content in just understanding. And for him, the new ambience in science is an ambience which not only wants to extend this to really needing to explain it, but explaining it in order to manipulate it. And of course, what recombinant DNA does promise us, amongst other things, is that the possibility of doing genetic manipulations across species in a way that they have never been done before. I mean, if I give the example of splicing the duck with the orange, this is ludicrous, but this is what it is possible. I mean, this is in theory what you can do. You could make a DNA recombinant of DNA from a duck with DNA from an orange and take it down to Maud's, where I've just had a lovely dinner. And moreover, what else this technology does for us is to allow us to do the kind of genetic manipulations, not only across species, but quicker and faster and more varied, even more bizarre than we've done before. And the technical fuss, the one technical fuss, of course, why there has been the fuss are the reasons why a Silomar conference was called in the first place by the scientists. Because they were working at the boundaries of two kinds of ignorance. Research scientists always work at the boundaries of ignorance anyway, but there was an extra kind. The first boundary of ignorance was the intellectual one. They had certain questions they wanted to answer, and they didn't quite know how to go about answering. The second kind of boundary of ignorance, which was on the whole rather new for biological science, is that they just didn't know how safe what they were doing was, and whether, in fact, there was likely to be a kind of immediate or gross environmental impact. And again, as you know, they dealt with this, I think, in a rather remarkable way, by a moratorium, by then calling a conference, and certainly by proscribing totally certain kinds of genetic experiments, which means that you may not, except now under the most rigid conditions, splice pathogenetic properties into this. You may not, except under the most, I don't think you may at all, but some scientists will correct me, you may not confer the property of antibiotic resistance onto an organism that hasn't got it. There are a number of experiments which still, even now, are forbidden. But this is really not the problem. The problem is that it is undoubtedly the first step to a kind of human genetic engineering, of which the example I've given of haemophilia is just one of the first steps. And we have to face it. We absolutely have to face it that people have gut reactions to this. Whether these are rational reactions or whether they are not in a kind of way, it doesn't matter. They have strong gut reactions to it, and I have gut reactions to this too. To the extent that when I wrote my book, Playing God, I set myself as an exercise to try to find a group of people somewhere in the world on whom I would be glad if we could do genetic engineering. Because I have the gut reaction. And I found them in a little village in the north of San Miguel in the Azores, and their descendants are in San Francisco and in Falls River. I'll just tell you this very quickly. In the middle of the last century, and many of the Azorians came over and settled in America, a number of Americans, of whom Nathaniel Hawthorne was one, went over and settled in the Azores. They thought the Azores was an eminently healthy place to live. But a sailor called Machado came over and settled in San Francisco. His family grew up. Another man called Joseph came over and settled over on the East Coast. And they carry a genetic disease, a genetic defect in their genes, recessive gene, which makes having children a nasty kind of genetic roulette. Generally, it's the women who have it, and the women will die by the age of 50. It manifests itself very much like Huntington's career, by a kind of neurological loss. You start to stumble, you look as though you're drunk, and then gradually you lose all kind of control and you die. But the problem is you don't know whether you've got it until after you've had your children. In other words, it doesn't begin to manifest itself until after you're 35. And so having kids is a kind of genetic roulette. You cannot tell beforehand. And of all those kind of groups, those were the people, one of the few people, and we think it came into the Azores via the Huguenots in the 14th century, that those are the kind of people where the very act of having children is such a monstrous roulette game. One would think that of all these kind of things, one would be very grateful if science could do something for these people. They can't even identify it in utero at the moment. But nevertheless, a lot of us do have gut reactions to genetic engineering, and the thing to do is to try to lay out and to try to find out what are our gut reactions against, and whether these gut reactions are reasonable gut reactions or unreasonable gut reactions, if you can lay these two things together. Now, of course, man has been doing genetic engineering for a very long time. It is nothing new in our history. Ever since the advent of agriculture and the development of cereal crops and the development of the selective breeding of animals to help our agriculture, we have been doing genetic engineering for a very, very long time. And of course, the problem comes in now because, of course, what happens is that there is the possibility of doing genetic engineering, not on men, being the ducks and the dogs and the cereals, but on us. And this makes the situation, or so it appears, rather different. This really makes the thing rather different. Where, and this is what's new in 1978 or 1972, where we can modify the environment or people, or where we can offer a new technique or the possibility of a technique where the manipulation of this is going to impinge on our autonomy or on our humaneness or on our conception of life and living, or where it is going to give the power to that to somebody else who isn't ourselves, then however much science might like to think we can and might wish we could do so. And we never actually could, even in history, however much science claimed that we did. And when conflicts do arise, it forces us to raise a very old question, but in a new setting, namely, where ultimately is the allegiance of this profession going to lie? And whether, whatever answer we give this question to the allegiance of the profession, where is it going to lie, we must ask whether that question must in fact not be asked again and again and again as new considerations arise through history. And basically, I see one of the great questions at the heart of this issue is the questions of morality of the profession and morality of all professions, and whether ultimately a profession's allegiance is entitled to be to the perpetuation and to the internal morals of the profession, or whether the time does not very often come when they have to not only take a transcendental aim for what they do, but consider wider society in what they in fact are doing. Now, again, I'm going to have to compress a little 19th century history. If you study W.C. Reader's book, The Rise of the Professional Men, or if you look anyway at the history of the professions, you will find that as the professions evolved in the earliest 20th century, one thing marked out the scientific profession from all the others. And there's a historical reason how this happened, and there's, no particular blame or praise to be given to anyone as to how this came to happen. But what we found is that as the professions evolved, almost all other professions, with the exception of the scientific profession, had two accepted norms of behavior: the own professional standards and status to which they subscribed, but also they had, at the same time, a real sense of moral responsibility towards society and of protecting society against the bizarre or the cracks or the men and women within the profession who might take advantage of them. They had, in fact, the notion of accountability. Accountability, direct accountability to society, was the price they paid for their professional privileges. And somehow scientists missed this out. And as I say, there's great historical reasons for this. The notion of an accountability of a scientific profession to society, this notion is not more than a quarter of a century old. And how it's come in and why it's come in at this time is, again, another question which would make a very good PhD thesis. It has got something to do with the fact that we now pay much more for it. It has also got something to do with the fact that it's a paradox of biological science, you see, that the more successful it's getting, the more capable they are of doing with living forms precisely what they will. The paradox is the more problems it generates for itself vis-a-vis society, who might indeed not wish these things to be done at all. Now, the 19th century was one thing. Galileo was one thing. Lysenko was one thing. And so whenever any scientist says to me, oh, well, if you try to put a stopper on what we're doing, you're just behaving like Galileo with the Inquisition, or you're just behaving like the Scopes trial, you know, you're etc., etc. I reject that analogy forcefully, because history does not stand still. We are in a new situation. Science is giving us new powers and new possibilities which did not actually face Galileo or Lysenko or Scopes, and therefore the analogy is only part valid. There is the most marvelous, incredibly funny play by Tom Stobbart called Jumpers, in which there is, it's all about a philosopher who is under the illusion that he's not under the illusion, his students are under the illusion that he is G.E. Moore, because he has a wife called Dorothy, and he does nothing to disillusion the students about the fact that actually he isn't G.E. Moore, he just happens to have the same name. Anyway, the play is a marvelous play because he's presenting his paper for the annual Philosophical Congress, and most of the play consists of him trying to rewrite this paper to the secretary, while unfortunately the principal of the university is, another one professor is murdered, and his body is found in a plastic bag in the park, and the principal of the university is under suspect. And into this hothouse of academic ideas with concepts flying around like drops of rain and syllogisms and, I mean, all the lovely things that philosophers love to have are just sort of abounding through the air, comes a poor old cop, an inspector of police, whose job it is to find out who done it. I mean, just simple. Who killed the other professor? And, of course, he goes around interviewing everybody and interviews G.E. Moore. And G.E. Moore immediately takes off about murder and death and killing, and launches into an enormous long spiel about how under certain circumstances and under certain possibilities, though he himself would of course never say that it was right to kill a man, nevertheless under certain circumstances one perhaps could make a justifiable argument to say that it was not indeed wrong that he should die. And off he goes. You can just imagine. I mean, you can write this for yourself. And this blows the professor's mind. I mean, the inspector's mind. He said, stop a minute. Let me understand this. Let me see if I got this straight. You are saying that though on the whole you would not go yourself and kill a man, and on the whole you would not say that it was right to murder somebody, nevertheless you would argue that under certain times and in certain conditions it might not indeed be wrong to kill a man. And Moore is delighted. Oh yes, you've got it exactly. You see, as Aristotle said in ancient Greece, and the professor said, but we're not in ancient bloody classical Greece. And this is true about present-day science. We are not in ancient bloody classical Galileo. We are not in ancient, and you can go on with this, we're not in the time of Darwin. We are not in the time of Lysenko. And every time when science produces us or brings us further, one step further into our intellectual understanding and our intellectual knowledge, or what it can do, we are forced to rethink afresh every time just what the problems are, just what are the value problems it might raise, just what it is possible, and what we cannot do, and what perhaps we might do. And the problem is, most of us, and this includes me, would love to have a rubric or an edict which says, in all kinds of historical situations, this holds and this holds and this holds, but actually we have to sit down and work it out afresh each time, and that is what is, in effect, being alive. So, when Norton Zinder of Rockefeller University gave the most agonized cri de coeur about recombinant DNA and smote his brow and said, how did we get into this horrible mess when all we did at Asilomar was to be terribly moral and try, how did we get into this mess? And why should we be moral at all? When, as a result of all this, we've had Mervolucci, we've had everybody, we've tried to be good, nice. Why should we go on doing this? All we've got is total misunderstanding. And of course, the terribly sad thing is that you have to say, by virtue of your commitment, you have to be moral. You have to be moral. as scientists by virtue of your commitment, and being moral as a scientist, I want to argue now in the 20th century, does not mean only not cheating on your experiments. I think being moral as a scientist in the 20th century, with the new powers that are yours to command, with the new possibilities as yours to command, is not only explaining to society what you are doing and bringing society along with you, but also questioning, not so much questioning your own motives, but seeing very carefully why you are doing what you are doing, and asking for to yourselves, in whose interest is it? Now, there is a new paradox. There is a new difficulty. If Asilomar was a totally unique event in the history of science, so too is the present situation, where, as I repeat, the possibilities of doing human genetic engineering, test tube babies, all the things you like to mention, are not in themselves bad. I am not, I feel at this stage I have to make a lot of things very clear, to use that awful phrase that Dick Nixon always used to. Let me make one thing very clear. I am not anti-intellectual, I'm not anti-scientific, I'm not anti-anything. I'm for knowledge, I'm for all these things, but it may be that we are beginning to get to a point with this where where just doing something for its own intellectual sake is by itself not quite good enough. By itself is not quite good enough. Now, science has always had a deep moral component within it. Science is one of the most moral and critical activities I know. It's moral both in the end to be achieved, which was a transcendental aim, which was understanding for its own sake. It was moral too by virtue of the ethic by which that aim would be achieved. And that moral provided a mold which stamped out, as we know, a certain quality of person. Or to change the metaphor, those morals laid down the boundaries of a niche into which certain people fitted. And George Steiner, giving the first annual Jacob Bronowski lecture, calling with the title Has Truth a Future, identified these. Identified the people who were absorbed by attraction, who were captured, who were enslaved by the notion of conceptual thought, who were in fact addicted to this. These people have, as Steiner said, a passionate criticism which has no reason but its own and a beauty of its own. People who are attracted to the sharp edge of beauty, and that's what we call a difficulty. Obsession is one feature, the predatory nature of the quest is another feature. And the hunting detective instinct is yet a third. These people combine the attitudes and attributes of Sherlock Holmes with those of artists of the greatest possible creative imagination in their capacity to think up possible worlds as mirrors of which the world may be. They're the visionaries of our cathedrals of the mind that mirror and glorify the world in which they represent. And society has always tacitly responded to this. It's deep in our cultural inheritance. We believe in Western society in the intrinsic value of truth, of those activities that lead to understanding rather than a big bank balance. And we know and we appreciate and we understand in society the beneficial consequences. Indeed, we have always accepted the imperative, quote, "the truth shall make you free," as a self-evident and a crucial element which has, in fact, in the past, united humanistic and scientific endeavor. And this deep-rooted assumption explained why some of the consequences of the recombinant DNA debate and some of the consequences of the new biology seemed always so shattering. It is for that aphorism, "the truth shall make you free," appears now to be under a challenge. And in view of what I want to go on to say, I think it is rather piquant that the lawyers who attended the scientists at Asilomar advised them to argue for recombinant DNA on the grounds of its value as a pure cultural activity without any reference whatever to the technological benefits that it could bring. If you listen to the tapes of the Asilomar conference, you'll see that the lawyers ran this line the entire time. I did think they did so partly because, of course, the benefits as well as the dangers of recombinant DNA technology were at that time very hypothetical, but they also did so, I think, because they felt that scientists can no longer take responsibility for the good use to which science is put, while abrogating responsibility for the bad use to which science is put. There has been, in the past, a remarkable speed of scientists in coming forward to saying how good science is, combined with a remarkable slowness, or rather standing still, when saying, well, of course, yes, it is put to bad ends, but it's not been our fault. But also, I think the lawyers argued this because I think that actually it is a cogent argument. It is an argument to which people have, in fact, always responded. That the truth shall make you free, that transcendental values are values which, in fact, distinguish men from the animals, which, in fact, are worth holding on to. And, of course, there has always been the counterattacks against science throughout history, what Steiner has called the laughter against Thales, the vengeance on Archimedes. We have the people who will argue that only the truth comes from illumination, not by rational acts. People who have always argued that the truth comes from divine revelation. People who have said, really, whether it's been from Goethe or from Blake onwards, that scientists in their analysis destroy the beauty, etc., etc., etc. And even now, the most subtle attack of all, the most subtle attack on rationality, I think, has come when those people who've argued, and I believe Marcuse is one of them, that even rationality is never disinterested, that logic itself is a weapon in the class struggle, and no fact is ever value-free, and so far it isn't the fact that the truth shall make you free, in fact the truth as promulgated in Western society, if indeed it is truth, shall in fact make you slaves. And added to that, we have some new attacks. We have the ones that began enforced by the Luddites of the social costs of technology are greater than the benefits. And as the scale of our technology grows, so in fact, the balance begins to shift. The balance begins to shift. That the technology is bringing us changes in our lifestyle, stresses, all kinds of things. I mean, I think you know all this backwards. That really, in the end, when you add it up, hell, it wasn't worth it. So shrug the whole lot off. So shrug the whole lot off. And one is left in a situation in which what happens is that we really find ourselves, according to these, deep in the dark night of the soul. We really are truly alone. It doesn't matter what the implication of the new biology is, whether it's problems of life or death, or individual or social good, or cloning or surrogate motherhood, or genetic engineering. The race for insight is leading us, they argue, into a moral ambush between certain categories of truth and our own hope of individual justice and our own capacity to influence our own events. All this was summed up for me, I guess, best of all, by the book critic of the New York Times, John Leonard, when he wrote in an address, actually, to the New York Academy of Sciences, the problem is that science has steadily reduced the number of things for which God can be held accountable and has pinned the rap for most of what is wrong on man. The objectivity of science, in many people's eyes, has become the enemy of man. Science has not only failed to save our souls, but worse, it has caused us to lose them in the first place. And so the guilt must be projected, and it is, back on science. And in our unhappiness, we in the humanities come to believe that the end of all the scientist's knowledge is manipulation, and that the end of all the scientist's interest is manipulation for his own particular end, not ours in society. And so we in the humanities revenge ourselves on his outrageous complacency by writing novels or making movies in which scientists perform badly in bed, just like psychoanalysts. Now, as Leonard says, the total reaction of science is nonsense. It's dangerous. It populates the world full of existential shrieks, and it's neither adequate nor sensible to resolve the dilemmas of a new biology by losing our nerve and saying away with all science. It is neither logical or sensible by dividing it up and saying let's have scientists and doctors on the one hand look after our health and let humanists take all the political decisions. Let's take knowledge from the one and values from the other and let the political institutions somewhere in between mediate. Because of course we need knowledge and values from both. And I invite some of you here tonight to think, what is the knowledge that we could usefully use and obtain from the humanities in our present problems? And what are the values which we could usefully use and take from the sciences and apply to our, and just switch the mirror image. But basically I think the problem, as Steiner has specified it, and as a problem as I see it, in the last resort, and I honestly do not know the answer to this question, I do not. In the last resort, are we going towards a situation where truth matters more than man? Could we envisage a situation, for instance, where a scientist's desire to understand in deep detail exactly what goes on in gestation, and let's suppose he can grow a child in a test tube right through full term, are we likely then to be in a situation where his interest in finding out modulates, mitigates his concern for that child as a child? Al Rosenfeld wrote a book called The New Genesis and interviewed as many scientists as he could who were trying to do just that. And one of them said, who wanted to be anonymous, I'm not going to do this the first time or the 10th time or the 20th time, but if I can grow a baby in a test tube up to full term, I'm going to do it. Every hormonal contact between mother and child aren't there then. I've lost a child by miscarriage and I know what I'm talking about. One is programmed for the bond, which I think would be absent. And it's very interesting to contemplate. If a child, as a result of this kind of experiment, comes out as a child sometimes does in nature, defective in some way, what is the scientist's obligation towards the child that he may have started? Will he feel the same bond as he does for his own child? And if so, should he, or if so, whose child is it? In other words, could we envisage, can we get into or out of situations where the disinterested search for understanding is being achieved at the expense of certain attitudes and values which up to now we have considered to be very important and uniquely human? Well, man's activities raised this question, didn't they? And man alone can answer it. Man, human beings that is, I'm not being sexist, must compromise with it. Because the capacity of man to search for truth and for understanding of the world is as fundamental to man as any other drives of love and sex and hunger and all this. Man is the very possibility of doing science at all. But we are in this very, very new and very, very perplexing situation where some of the things we may want to do in our search for knowledge and understanding may impinge on the autonomy of people, other people, and of individuals like a small child who are unable to speak for themselves. So where do we go from